Welcome to Eureka Math. I'm Mr. Schenkel. This is Algebra, Module 1, Lesson 1. Let's get started. All right, I've got an elevation versus time graph, and we're going to try to describe what this person might have been doing. Well, when we do this, we want to look at time intervals. So I'm going to start here, and I'm going to just draw a line straight down. That's maybe a little bit more than 3 seconds, but close to 3 seconds. So that time interval from 0 seconds all the way to, let's say that's a 3. It's pretty close. The elevation is changing. So as we move from left to right and time is ticking away, elevation is going up. So the elevation changes from 0 to 10 feet in 3 seconds. So we can actually talk about that rate of change, which is 10 feet in 3 seconds. And isn't that slope? That's the change in y over the change in x. So the slope of that line we could call 10/3. And then our next time interval looks like it's about right here. I'm going to move that a little bit if I can. Let me see if I can do that. I can't. So anyway, from 3 to probably a 4. Let me try to get it in the right spot here. Yeah, probably 4 seconds there. So from 3 seconds to 4 seconds, that's another time interval. And during that time interval, there's no change in elevation. So we get this flat line because elevation isn't changing. We started at 10 after this is a minute, not seconds. After a minute, there's no change in elevation, so there was no moving up or moving down. And in that time period, we moved 0 feet in 1 minute. And let me change this. This is not seconds, this is minutes. Okay, so 10 feet in 3 minutes for the first time interval. The second time interval, we went 0 feet in 1 minute, so that slope is 0. And that makes sense. A horizontal line is a 0 slope. Okay, and then let's see. We've got another time interval here. That's going to be about right there. And that's going to be less than a minute. Probably, I don't know, maybe 30 seconds. So that time interval, there is a change in elevation. So we went from 10 to 15 feet, so that's a change in elevation of 5 feet. And how long did it take? Well, 0.5 minutes, 30 seconds. 0.5 minutes, which is the same as 10 feet in 1 minute. So 10 feet in 1 minute would be our slope of that section. And we can just keep going, right? Every little bit of time interval where there's a straight line, we can identify what's going on. So in this case, we've got another one, and this is maybe 4.5 to 6 seconds, so 1.5 minutes, and no elevation change. So right here, 0 elevation change, 0 feet up or down in 1.5 minutes. So doesn't really matter that I have a decimal down there because that's going to be 0. Slope 0, parallel line makes sense. Okay, let's see something else. Here's one down here. So we go another time interval from 6 to 7, it looks like. So 1 minute passes. And during that 1 minute time period, we go from 15 feet down to maybe 1 feet. 1 foot. So in this time interval, we go down 14, negative 14 feet in 1 minute. So there's a slope, negative 14. And then there's another right here. Looks like 1 minute again. I keep wanting to call these seconds. 1 minute again, and in that minute, there's no elevation change, so 0 over 1. That's a slope of 0, parallel line again. And then there's one more time interval, 2 minutes from here to here, and that is a change of 1 foot in 2 minutes. So that change, let's see, this last change right here is a down 1 foot in 2 minutes. So a slope of negative 1/2. Well, there's definitely some going up and some not going anywhere, up or down, and then some going down areas. So maybe it's a flight of stairs, like the example we had in class. Maybe it is a ladder, except for the time interval. Because if we look at this first one, a gain in elevation, right, if we look at this first time interval right here, a gain in elevation of 10 feet, but it takes 3 minutes to do that, well, that's not a ladder, unless you're moving extremely slow each step. That's probably not stairs, 10 to 15 stairs in 3 minutes. That's moving pretty slow as well. Maybe this is a walk up a mountain with switchbacks, where it's a very gradual incline, and you can continue to go up, but it takes time. So it's not too steep and hard to do, but switchbacks on a mountain. That could be the case. It could take 3 minutes to gain 10 feet of elevation if we're gradually going uphill. That's possible. And maybe these sections where we're not going anywhere are resting periods. If you've ever climbed a mountain trail, there are times that you want to just take a break for a second and let your muscles catch up. So that could be it. Lots of different possibilities, but this could be one. We could also be talking about, maybe a hot air balloon, maybe 10 feet gain in elevation over 3 minutes. Their balloons are slow, but probably a little quicker than that. Anyway, you can see that whenever we talk about the ups and downs of this elevation time graph, we have to talk about the change in elevation over an amount of time. So the time interval is important as well as the change in elevation. All right, that is our first look at these functions. And last thing I want to point out is that each of these lines, let me get rid of some of this stuff. Each of these lines are their own linear function or linear equation. And it's just like we're taking a bunch of different ones and putting them together. So this first line would be this one. If we continued it, that would be the line, and that line would have an equation that would describe that line. And then we would have another line, maybe this one right here. That line would have an equation. But we're only taking pieces of it. So this is called a piecewise function, where we're just taking little bits and pieces of different lines. So there's a different line. The next one would be this line here. I don't know if I can get it exactly. Yeah, that line. Okay, but we're only using a part of it, and then we'd have, obviously we could just keep going here, and we could look at all these different lines. Here's another parallel line to the other horizontal parallel line, and then that's another part, and then we could take this one, which is this line, and again, we're just taking pieces to show what the overall movement was on this graph. There's another one, and then the last one would be this one. Well, not quite that one. Let's try again. Not quite that one either. Yeah, something like that. So all those different lines with their own different equations, but we're just worried about all of the bits and pieces of those lines. When we put them together, that is a piecewise function graph. All right, that's it. I hope that helps. That's lesson 1. See you next time.